Hi, boys and girls. Today we're doing Chapter 11, Lesson 2, Solving Capacity Problems. And the learning intention, this isn't the only reason to learn how to solve capacity problems, but I thought it was probably one of the coolest. I'm learning to solve problems using capacity so I can do successful science experiments. So when you are a little bit older, and well, at least back in school anyway, and you have to mix some liquids and you need so many milliliters of this and so many milliliters of that, you'll be able to figure out how much you should have and whatnot. And so I thought that was kind of a cool reason to learn how to solve problems using capacity is for science. So these are the pages that we'll be doing today in your book. Pages 639, 640, and 641. So let's get started with the very first page. And remember, if you're unsure what these different measurements mean, make sure that you refer to your anchor chart. So that will help you know what milliliters and liters are. Okay, so Emily used I was going to say this too. The 3-read works really well for these kinds of word problems. So I'm going to do that strategy with you just to remind you how that works. So, Emily used some milliliters of lemon juice and some milliliters of water to make lemonade. How many? Oh, no question. Okay, so she needs lemon juice and she needs water to make lemonade. Now, you probably know from trying to make lemonade yourself that you've got to get those measurements right, or you are going to be puckered up for the rest of the day, or you're going to be like, was there any lemon in that water? So let's find out what the recipe is. Emily used 240 milliliters of lemon juice and 960 milliliters of water to make lemonade. Okay, that sounds a little bit more reasonable. You need more water than lemon juice, but you want too much more. So let's see what the question is. Emily used 240 milliliters of lemon juice and 960 milliliters of water to make lemonade. How many milliliters of lemonade will she make? So if we are adding water and lemon juice to each other in order to find out how many milliliters that is, we know we're going to need to add. So and like they said here, we're going to add to find the unknown. Excuse the notifications on my phone. So 240 plus 960. The unknown is what that total is. So 240 plus 960 equals how many milliliters? Now, we know in 3rd grade that we stack our addition and subtraction problems, always. So let's go ahead and stack this and add it together. 240 plus 960. Now with addition, you don't have to worry about which number comes first because commutative property of addition says you can add add-ins in any order and get the same sum. So we are fine with adding it in this order. 0 plus 0 is 0. 4 plus 6 is 10. So so 40 plus 60 is 100 actually. So we put down the 0 that's in the tens place. We carry the 1 that's in the hundreds place. I see a 10 here. 9 plus 1 is 10. 2 more is 12. Because I have a thousands place, I need to put a comma after it. So 1,200 milliliters. If you can hear music in the background, that's my daughter in her room next door. I'm doing this from home. The unknown is 1,200 milliliters. Emily will make 1,200 milliliters of lemonade. Okay, so let's scroll down now and let's do the next one. Get this all in here so you can see the pictures. There we go. The total capacity of some pitchers is some liters. What is the capacity of each pitcher if each has an equal amount of lemonade? Oops, I read the question. Let's do it again. The total capacity of some pitchers is some liters. Okay, so I have pitchers and I know that there's stuff. Well, we're going to have stuff in them, but I know that altogether it's 24. So let's read it now with the numbers. The total, I don't know that it's 24. I know that these 8 pitchers have a total amount of liters. The total capacity of 8 pitchers is 24 liters. I know that all 8 pitchers in total hold 24 liters. So now let's read the question. This one totally threw me off because it's written weird. Okay, the total capacity of 8 pitchers is 24 liters. What is the capacity of each pitcher if each has an equal amount of lemonade? Okay, so we're going to write an equation with the symbol for the unknown, then solve. Because I keep seeing numbers like each and equal, I know that I'm either multiplying or dividing. Now, they've already given it away down here, but I want to walk you through the thought process because you won't be getting hints like this when you take a test on it. So I have each pitcher. I see equal amount. So I know that I have to either be multiplying or dividing. So I'm going to go ahead and set up my multiplication number frame like we did when we were first learning multiplication. Okay. And remember that this blank here is the total. This is groups. I'm just going to put a G because there's not enough room to write. And this is items, or in this case, it would be liters. So I have 8 pitchers. My groups are the 8 pitchers. I don't know how many liters each one has in it, but I do know I have a total of 24 liters. So I look at it and say, if I have an unknown factor, I can use division to help me solve that. So what I'm going to do is I'm going to put my total first. Remember that in division, your total goes first, divided by, and then I have my groups, which is 8. 24 divided by 8 is 3. So find the unknown. 24 divided by 8 equals 3. There are 3 liters in each of the pitchers. The unknown is 3. And I can count it up to make sure that I'm right. If I put 3 over each of these, I can count by threes. 3, 6, 9, 12, 15, 18, 21, 24. Use the inverse operation to check. Okay, so 8 times 3 is 24. So the inverse is reasonable. Or the answer is reasonable. Geez, I need to slow down. Okay, let's look at the next page. Dylan is helping his dad wash the car. His dad filled up some buckets with soapy water and some buckets with clean water. The capacity of each bucket is some liters. Okay, so he's got buckets with soapy water, buckets with clean water, and I know each of the buckets has the same number of liters in it. So let's find out what the numbers are. Dylan is helping his dad wash the car. His dad filled up 2 buckets with soapy water and 2 buckets with clean water. My phone needs to stop notifying me. The capacity of each bucket is 9 liters. What is the, then there's a question. Okay, so 2 buckets and 2 buckets. Each bucket holds 9 liters. Now let's read it with the question. Dylan is helping his dad wash the car. His dad filled up 2 buckets with soapy water and 2 buckets with clean water. The capacity of each bucket is 9 liters. What is the total capacity of the 4 buckets? So, because I see the word each, okay, each bucket, I see total, so I know it's going to have to go together. So let's see what else. Yeah, those are my clues. So I'm probably going to be multiplying because multiplying gives you a total. Dividing does not. You use the total and you divide it up. So I know it could be addition too. I would just use repeated addition. So it says find 4 times 9, label the capacity of each bucket. So let's go ahead and do that. We know that each bucket has 9 liters in it. And so here's where you could use repeated addition. 9 plus 9 plus 9. These 2 are 18. These 2 are 18. And if you add 18 plus 18, it equals 36. So let's go down here. 4 times 9 equals 36. There are 36 liters of water in the buckets. Okay, so let's scroll down. Write an equation with a symbol for the unknown, then solve. Okay, so find the total capacity of the liquid shown in the containers below. Now, the first one's easy because you can see right where it levels off at, right? Oops, wow, that was weird. That didn't work so well. So right there, the water is right on the line. But here, it's halfway in between two lines. So halfway in between 100 and 150 is 125. Okay, because between 0 and 50 is 25. So halfway in between 100 and 150 is 125. So I'll give you that hint. So you're going to write the equation with the symbol for the unknown, then you're going to solve it. So first, write your equation or your number sentence and use a symbol for your unknown. Just do that part. Don't worry about the answer. Pause the video and then come back and find out what the equation should be. Okay, so the total capacity of the liquid shown in the containers below. So I know that it's going to have to equal something. So I'm going to use N. I don't care what your unknown was. Okay, I know this one's 150 and this is 125. Okay, so the total capacity of the liquid shown in the containers below. This is known. This one right here is known. This one right here is known. What is not known is the total capacity. So that's why I left a letter after the equal sign. Now I want you to solve it. Stack your numbers, find your answer, and then pause your video, and then come back when you think you have the answer. Okay, so we're going to stack the numbers because we stack addition and subtraction in third grade. Okay, and now I'm going to add these two together. So in the ones place, 0 plus 5 is 5. In the tens place, 5 plus 2 is 7. And in the hundreds place, 1 plus 1 is 2. 275. So N equals 275. And what's the label? Milliliters, lowercase m, capital L. That's how your label needs to look. Not little m, little l, not capital M, capital L. It's little m, capital L. Lowercase m, sorry. Okay, let's go on to the next word problem. Peyton's tea kettle holds some liters or some milliliters of water. She uses some milliliters of water for a cup of tea. Okay, so her tea kettle holds a certain amount of liters, which we also know is a certain amount of milliliters, and she's going to use some of the milliliters for a cup of tea because you don't want to drink liters of tea. You want milliliters of tea. Okay, so now let's read it with the numbers. Peyton's tea kettle holds 2 liters or 2,000 milliliters of water. She uses 350 milliliters of water for a cup of tea. All right, so 2 liters is the same as 2,000 milliliters. So we do not need to use the 2 liters in our equation because they told us that 2 liters is the same as 2,000 milliliters. Okay, she's going to use up 350 milliliters of water for her tea. Let's find out what they want us to do with this. Peyton's tea kettle holds 2,000 milliliters of water. She uses 350 milliliters of water for a cup of tea. How much water is left in the kettle? Okay, so I know that this word left, if it's left behind, that means I had to subtract. I had a bunch, I took a little bit out, what's left in there? A smaller amount than started, so I'm going to have to subtract to make it smaller. Okay, I'm not going to divide because I didn't take out a bunch of cups of tea. I just took out 1 cup of tea, so I'm just going to subtract. So, write your equation. Don't find the answer. Just write the equation and then come back and find out what your equation should be. Okay, so 2,000 milliliters of water. Those are zeros, not sixes. Minus 350 milliliters equals, and because we're talking about water, I'm going to use letter W. I don't care what your unknown is. Okay, now I want you to stack those and subtract, and then come back and find out the answer. Okay, so let's stack them. I need some space to write. I think I'm going to write on the tea kettle. I think that will be fun. 2,000 minus 350. Now remember, in third grade, our bigger number has to go on top when we subtract. It's not always going to be the case, but for third grade, that's the rule. Big number on top when you're subtracting. And we always stack addition and subtraction problems in 3rd grade. Okay, 0 minus 0 in the ones place is 0. 0 minus 5 in the tens place. If I have 0 milliliters of water, I can't pour out 5, can I? So I'm going to need to borrow and get some more milliliters from other columns. Well, the hundreds place still has 0 in it. So I'm going to walk over to the thousands place. I'm going to take 1 out of there and leave 1 behind. This 1 becomes 10. 1,000 is the same as 10 hundreds. So I'm going to put a 10 here because now I have 10 hundreds. I'm not done though. I need to take 1 out of this 10 and leave 9 behind and take my 10 tens over here and put it in my tens place. So 10 minus 5 is 5. 9 minus 3 is 6. 1 minus nothing is 1. And I need a comma after my thousands place. So 1,650 milliliters. 1,650 lowercase m, capital L. If you did not understand how to do that subtraction, rewatch this part of the video again and rewrite it and do it again so that you understand it, because you need to be able to subtract with borrowing. We'll be doing that soon before the end of the year. Okay, on to the independent practice. So your job is to write an equation with a symbol for the unknown, then solve. You're going to do exactly what we just did in guided practice. Okay, so now look at this beaker right here. This is between 40 and 60. So counting by tens, there is a number in between 40 and 60. Your job is to figure out what that is, then use it in your equation, and then tell what the unknown is. Okay. Let's see what else. Yep. So you're going to write equations for each of these. And then you have a problem down here, and you're going to fill in the blue blanks. Okay. So there you go. That is solving problems with capacity. Again, if you're unsure what milliliters and liters are, go back and look at your anchor chart. Go back and look at the video that comes with the math lesson from the book. Rewatch this video. If you still have questions after that, you can ask me in class. There you go.